Hi guys, sorry I'm not there with you today. I'm going to go through what we would have done together, the review for your test, and then I'm going to give you time to work on the review in class. So the 7.1 to 7.4 test is what you're preparing for, which is Wednesday. It is scientific calculators only, so keep that in mind. The first two sections, actually the first three sections were on your quiz, and then we added 7.4, which is what we spent the end of last week working on. So when you go think back to 7.1 and 7.2, this was your systems of equations. Remember there was graphing, which you'll have one question that you'll have to graph, and so you'll want to print the answer sheet that has the graph on it, which will be attached to the test review assignment. Then remember that there was two special cases within graphing, which is if they don't intersect at all, that's a no solution, which would be NS. And if it's the same line, then it would be all real numbers, which would be ARN when you type that in. Actually, this you'll write directly on your paper. Then will come the other systems, which you can solve using substitution or elimination. The special cases there are if the variables cancel and there's a false statement, that's a no solution. And if the variables cancel and it's a true statement, so something like if it said 0 equals 1, obviously that's not true, so that would be a no solution. And if it said something like 0 equals 0, then that's a true statement, that would be all real numbers. The word problems come from these sections, and we saw things specifically the ones you saw in your quiz, which are the break even. And remember, this is the one where you're looking for the number of units. And you're always rounding these up when they're a decimal. So even if it was like 31.1, we would say that that's 32. If it's 31 even, we keep it 31. So you don't round it if it doesn't need to be rounded. But if it does need to be rounded, then we're going to round up because you're looking for the point in which you don't lose money. So you'd have to round that up. And then we had the equilibrium, where it looks for the number of units and the price per unit. So there was two parts to those answers. And then the other word problems varied. They could have been, perimeter based or some sort of geometry area, anything like that. And then they could have been, we did ones with ticket prices. We did one with interest. So all of those can come from the word problems in that section. And there's some examples on your quiz review, on your actual quiz. Feel free to ask the other sections what their word problems were because they were all different. And also on your test review. Then came 7.3, and on 7.3 on the quiz, we did the triangle systems, or the new one, new two method, but we won't have time for that and the matrix. So the only thing you're going to get from 7.3 is your partial fraction decomposition. So I'll work through a quick example with you. Most of you did pretty good on this on the quiz, which is a good sign. You just want to definitely refresh because it's been about, a week and a half since you saw that stuff. So the partial fraction decomposition, remember that the first thing we want to do is look at our denominator and see if it can be factored. So this one would be factored into x minus 5 and x plus 1. And then we separate them one fraction per term there. So I'd get a over x minus 5 plus b over x plus 1. And then we multiply the numerators of each by what the denominator is missing. So the a is going to get the x plus 1 and the b is going to get the x minus 5. Then we look at just our numerators here. So I'd get 3x plus 2 equals a, x plus 1, plus b, x minus 5. We want to figure out what's going to cancel each of these out, which you can do there or back here. Set these to 0, and I get x equals 5 and x equals negative 1. So then I have to plug each of those in. So if x is 5, then I'd get 3 times 5 plus 2 equals a, 5 plus 1 plus b, 5 minus 5. I get 15 plus 2, which is 17. A times 6. And then one of these should cancel out. This time it's the b. So I get a times 6. Divide. And I get a is 17 over 6. Then I repeat that for b. So I'm going to plug in negative 1 this time. 3 times negative 1 plus 2 equals a, negative 1 plus 1 plus b, negative 1 minus 5, negative 3 plus 2, which is negative 1, equals, this time the a cancels, b times negative 6, and then I get b is negative 1 over negative 6, or positive 6. So then I need to take them and plug them back into these fractions And I would get A, which is 17 over 6 over x minus 5, plus B, which is 1 over 6 over x plus 1. But we cannot leave the fractions within the fractions. So these come down to the bottom of each of these. And I'd get 17 over 6 times x minus 5 plus 1 over 6 times x plus 1. You don't want to distribute that out. You want to leave it like this, or you could take it a step further, and that is to pull out a 1/6. And then I'd get 17 over x minus 5 plus 1 over x plus 1. So either of those answers is fine, okay? You do not, I repeat, do not want to leave the variable, the fraction within the fraction. You can't leave your answer in complex fraction form. And this is one of, so you're going to have 2 questions that are on the answer sheet, just like your quiz, which are, well, 3 actually, which are your graphing, this one, and then the very last one, which we're going to get to in a minute, because that's your matrix one. The rest you'll work out on your answer sheet, but you'll type in those answers for the systems and the word problems onto Canvas. Okay, so 7.4 is solving a system using matrices. So the directions will say exactly what this is, maybe not word for word, but close enough. Solve using Gaussian elimination with back substitution. So we're going to solve it one way. And then we're going to, what we did on Friday, rewrite the row echelon form and then solve it using Gauss-Jordan. So if you are watching this in class, if you are the sub, if you will pause the video after they copy down, actually you can pause it now, have them copy down this question, complete it. I would say give them about, 7-ish minutes. And then when everybody's ready, go ahead and hit pause again so that they can watch the process. If you're at home and you're watching this, I would do the same thing. Hit pause, try it, so that you get the practice on it. And if you get stuck, you can go ahead and play it. Or when you're done, go all the way through. I'll give you a hint. These are all whole numbers. All right, so the first thing I'm going to do is write the system. -1, -5, -5 and 2, 4, -5, 4 and 19, 1, 5, -1, -20. Then I want to get the 1 in that top left corner. So you can multiply everything by -1, or you can switch row 1 and row 2, row 1 and row 3, which is what I'm going to do, because eventually that 1 will be easy that it's negative. 1, 5, -1, -20, 4, -5, 4, 19, -1, -5, -5 and 2. Now I want to zero where the 4 is. So I'm going to multiply, and I can do the top by -4 and add it. Or because the -1's already in the bottom, I can do the bottom by +4. So 4 row 3 plus row 2, -4, -20, -20 and 8, plus 4, -5, 4 and 19. 0, -25, -16 and 27. And that replaces row 2. 1, 5, -1, -20, 0, -25, -16, 27, -1, -5, and 2. Now I want to zero where the -1 is. So I can add row 1 and row 3, sorry. Zero, 0, -6, -18. That takes the place of row 3. And we actually got lucky and got 2 zeros. I want this to be a 1, so I'm going to multiply everything by -1/6. Okay, now I need this to be a 1, and this is where this system was not lucky. I have to multiply everything by -1/25. So I'm going to rewrite it again. 1, 5, -1, -20, 0, 1, 16 over 25, and 27, -27 over 25. 0, 0, 1, 3. So this is in row echelon form. I've got my diagonal of 1s with my zeros below. From here, I'm going to write this system Here's my triangle system. So I already know z equals 3. Now I can take that and plug it back into y plus 16 over 25 times 3 equals negative 27 over 25. I would get y plus, this would be 48 over 25 equals negative 27 over 25. Subtract it. Negative 75 over 25, and y is negative 3. And then from there, I'm going to take the z and plug it into the top row, and take the y and plug it into the top row. So I get x plus 5 times negative 3 minus 3 equals negative 20. X minus 15 minus 3 equals negative 20. X minus 18 equals negative 20. Add that 18. Add the 18. And x equals negative 2. So my solution set here is negative 2, negative 3, and 3. Has to go in XYZ order. I'll tell you right now, the one on your test is also going to be a whole number for this. So use that to let you check it. It doesn't mean you're not going to get fractions all along the way. Like we got fractions back here. But it means that when we get to the answer, it should be whole numbers. Okay, so that's the first part, which was solving using Gaussian elimination with back substitution. Then you're going to take your row echelon form, which might be different depending on how you solved it. Okay, and now we want to get it into reduced row echelon, which is the diagonal of 1, zeros below and above. So if we had done this all the way through to Gauss-Jordan, because that's what this next steps would be called, I probably wouldn't have gotten this one had it caused these fractions. But because they're already there and we only need to really use that row once, it's not that big of a deal. I need a 0 here. So I need the bottom row to be negative 16 over 25. So I'm just going to multiply row 3 by negative 16 over 25. So negative 16 over 25, row 3 is 0, 0, negative 16 over 25. And then this times negative 16 over 25 is what we got before, which is negative 48 over 25. And then I want to add it to row 2. So 0, 1, 16 over 25, and negative 27 over 25. And I get 0, 1, 0, and then these two are that negative 75 over 25. So this is 0, 1, 0, negative 3. And that takes the place of row 2. So 0, 5, negative 1, negative 20, 0, 1, 0, negative 3, and 0, 0, 1, 3. So now we need the zeros in these locations, and it doesn't matter what order we get it in. If we're going for this 0, we have to combine it with row 3, and if we're going with this 0, we have to combine it with row 2, otherwise they won't cancel. So let's say we get that negative 1 first. Row 1 plus row 3 will actually cancel that out. So 1, 5, negative 1, negative 20, 0, 0, 1, 3, and I get 1, 5, 0, negative 17. That replaces row 1. 1, 5, 0, negative 17, 0, 1, 0, negative 3, and 0, 0, 1, 3. Then the last 0 I want to get is where the 5 is. So I do negative 5, row 2, plus row 1, 0, negative 5, 0, 15, 1, 5, 0, negative 17, 1, 0, 0, negative 2. And that replaces row 1. So if we've done it correctly, we should get the same answer both times, which is what happened here. Negative 2, negative 3, and 3. And it's a great way to check your answer, okay? If you get fractions or horrible numbers, remember that you need to make sure you go all the way through your test before you go back and try to find your mistake, okay? But this type of problem, which will be the most amount of points, is going to be that. Okay, you're going to build it using Gaussian elimination with back substitution, which is the row echelon we did over here, and then use the back substitution, which was all in here, to get to the answer. Then rewrite your row echelon form and continue to get it into reduced row echelon form, which gets you the answer using Gauss-Jordan. So you're going to spend the remainder of the class period to work on your chapter review. This is linked to the assignment. That is your chapter review. Notice it starts with 7.1, which is substitution, and it's actually graphing. With these, you do not need to use substitution or graphing or substitution. You can use elimination. That's fine. 35 is the graph, so you want to make sure you graph that on a coordinate grid. And then you've got some more word problems there in 2. 7.3 is your partial fraction decomposition, and 7.4, which is that last page, is your Gaussian elimination, back substitution, and Gauss-Jordan. You definitely need to practice these. The more you practice at them, the more comfortable you're going to be. Please, please, please be careful with your positive, negative signs and show all your work. And then make sure you submit the notes that you for your review. Okay, to the assignment. Before the end of the class period, and it should include the work for that Gauss-Jordan and Gaussian elimination example. Again, before the end of class. Have a great day, and I will see you tomorrow.